Welcome to the Shaw Almex Cleatwelder. We're looking at a 72-inch model here, which means we can weld cleats on a 72-inch wide belt, or of course under. A few of the features: the machine is on casters, so it's easily wheeled into location. Voltage requirement is 220, 230 single phase. It's got Leicester hot air gun, which is the highest quality on the market. A couple of other important notes: the carriage is powered and the profile wheel is also powered. And what that allows us to do is lay perfectly flat cleats. We don't get any dishing or concavity to the cleat when it's set up properly. In on the control panel, very simple control panel. We have the jog feature, forward, reverse. We have the run feature, forward and reverse. We have a numerical readout for the wheel speed, a numerical readout for the slider speed. And the importance of this is it gives you repeatability. So once you determine that your certain type of cleat with a certain type of belt is this number and that number, then you can easily repeat without too much time in setting up. We're going to focus here on the versatility of the profile wheel. So we're going to start with showing you how it comes apart. There's 4 bolts. And the center one. You'll notice that there's a set of spacers. These range in various thicknesses and can be grouped together to get the optimum thickness required. Front face, you'll notice, comes off, and inside we have another grouping of spacers. So all in all, we have about a 1-inch thickness comprised of 8 spacers, all varying in thickness. The idea of the spacers: the machine is designed to weld right from the very small type base cleats to larger type base cleats, as well as what we call in the industry beef cleats, which are generally 1/2 inch thick. So ideally, instead of having all kinds of different profile wheels, what we have is the ability to separate the 2 halves of the wheel. And essentially what we're looking for is at the base of the cleat, right this area here, we want to be able to put the correct thickness in there. And that looks pretty good right there. And what I'm looking to do here is have the wheel, so when it seats on the radius, you'll notice the wheel is radius cut, that I'm seating so it's in this type of position. I don't want to be squeezing on this at all, because as the wheel moves along, it'll try and pull the cleat back off the belt before it's had a chance to cool. notice also there is a setting point. There's 4 holes to allow clearance for the bolts, and that's a set hole there. So you want to align those up so that the set hole lines up. And here's your set pin. And there it is there. Be sure that the radius side of the wheel goes to the inside on each side. We recommend that you return all of the wheels or all of the spacers so that they don't get lost. I'm going to return these now. When you're tightening these in, remember that there's no strain on these. You just want to snug it. We don't have to really torque that bolt in. You're just snugging it up. And there we go, ready to weld. So we've now set the gap between my 2 halves of my profile wheel, and it's designed for this cleat here. A good test is if you push the cleat in, it basically should just drop out. And then I know that I'm not pinching it at all. I don't want to be pinching it down at the bottom, because as the weld occurs, if it's pinching, it'll want to pull the cleat back off on the welded side before it's had a chance to cool. So you don't want that to be happening. Also, one note, it's good on your laser gun when you fire it up, give it at least 2 to 3 minutes to come up to the temperature that you set it. It does take a little bit of time on the electron laser gun to get up to that full heat. What may occur if you attempt to weld too early is halfway through your cleat, then you'll start to either over weld it because it'll be reaching its temperature at that point, or you'll reach optimum weld and the first 12 or 14 inches may be a cold weld. Okay, this is another feature of the cleat welding machine. These inserts are for welding V-guides laterally across the belt as a cleat. So starting down here with this smaller thin one, this one is for a K6, or sorry, a K8, a K10, K13, K17, and a K22. The K10 will also work on imperial sizes. For example, K10 would be your O section, K13 is your A section, K17 is your B section, and K22 is your C section. These are clearly stamped on the unit in the center, and you'll notice the bolt-in pattern is identical to our profile wheel. So essentially, when using these, you would remove all the spacers from the outside and use this as your only spacer going inside of the, in between the two halves. The diameter of these have been optimized so that the V-guide will still protrude beyond the bottom of the profile wheel, but it'll seat on something firm, so you'll be able to weld those guides across the belt. So, let's see what we got here. We'll do another one. Real speed.
How's that looking?
Pretty good. Okay, so firstly, this here is an example of a cold weld. I was able to pull this cleat off after I welded it. So even though it looked here like I had good flow and good melt, and this cleat would have looked like it was welded good, when I pulled on it, it separated the two pieces. You see a little bit of good weld here where it's ripped the top surface of the belt right off with the cleat, but the rest of this cleat was cold weld. Not good. Generally, to correct this doesn't always mean you put the heat up. I actually, for my second cleat, turned the heat down, but also gave it a slower carriage speed. Cold welds usually occur for one or two reasons. You're either not high enough on your hot air gun, or the second reason is you're trying to weld too quickly and not allowing the hot air to flow the surface of the belt and the cleat. So a lot of times you're looking at slowing the carriage speed down, but also turning your heat down a little bit too. Because this is obviously melting the surface of the belt. So I want to slow that carriage and turn the heat down. So that's what I did to this weld, this belt here. And when I slowed it down, you can see that where I started, I've got this curvature. Because I slowed my carriage speed down, but I left my wheel speed at the same speed. So my profile wheel was turning faster than the carriage, and it creates a concave. In the event that I had adjusted that wheel slower than the carriage, we would see a hump, like this one up here. If you look at what I'll do, I'm just going to jog this out of the way.
Okay.
Can you get in there and see that all right?
I went down ground level so I could see it moving up.
Okay. So you can see in here we have a convex bump, which that is due to a wheel speed being too fast, or slow, sorry, too slow. So wheel speed too slow, convex, wheel speed too fast, concave. Looking down here at my adjustments that I made, this cleat, I can't pull this cleat off. If I do pull this cleat off, it's going to rip the entire surface of the belt with it. So this cleat is a very good welding through here. So the important thing to understand, when you first get the piece of equipment, you're going to have to work a little bit with your carriage speed, your heat, and your wheel speed based on what type of cleats you're using, who the manufacturer is, are they hard, are they soft, PVC, urethane. But once you get it, then as long as you don't change your vendor for your cleats or big guys material, then you'll know your setting. So what we're going to do now is we're going to set up at the settings that I've seen done, and we're just going to weld a cleat across the entire belt. Wheel down. Go to 0 point. Loosen the gun. You'll notice at the other end, I've just got my wrench strip handy. To do my run on. You know what? And I can return. Going to slide a cutting board underneath. Take the cleat off. You'll note if have a nice flat cleat, nice and welded. We don't have any curvature. Okay, so in the event that your cleats are inset, all you need is some Teflon clear glass belting. You would trim it to the width, and it's reusable over and over again, but in this case, I've got about a 60 millimeter indent requirement. And all we're going to do is we're going to put the Teflon right on top of the belt. Okay. Drop our wheel down. We're going to jog forward. And just on there. Now, I'm going to start my cleat. I can jog forward a little more. I'm going to start my cleat welding right on that Teflon, which of course it's not going to stick to. And as soon as it comes off the Teflon, it's going to start welding. So that is how we're going to inset a cleat. Now in the event that you have an inset, and then in the middle of the belt you need another, say, 1-inch gap, and then continue welding. And then on the other side, the same thing, you're going to have another piece of Teflon for your inset. So you're going to take one plate and just weld all the way across, and then you're going to part it. Then you're going to part it where your Teflon is. And you're just going to cut down and remove that chunk of plate. Like cooled the gun, so I'm just letting it come back up to heat.
Yeah.
I'm gonna show them. So again, if I have an inset on the cleat and then in the center of the belt, now I'm not measuring this out perfectly, but you would position your Teflon in the center of the belt. And we're just going to continue welding right over it. And then at the far end, we would have another piece of Teflon, which we're not going to go that far. And you just weld right off the belt, and then you're good to go.